Homework 1.7, Inequalities, Video 2. Homework due Saturday, May 16th, 2020 at 11:59 p.m. I want to go ahead and mention that the next 2 or 3 videos are associated with questions 1 through 7 on Homework 1.7. So you may want to go ahead and open up your homework to these problems. We won't be able to, well, you may be able to. I won't demonstrate every variation in this one video, hence part 1. I'm anticipating a part 2 and possibly a part 3. Well, let's actually start solving some linear inequalities, and I'm not sure if I've actually defined this in previous videos, but the word linear algebraically means the highest power is 1. So if you'll notice these variables, the highest power is 1. We're going to solve each inequality and express the solution set as a number line and an interval. When it comes to solving basic linear inequalities, it's almost just the same as solving an equation. Your objective is to get the x by itself, and you achieve that by doing moves to both sides of the inequality. For example, if we wanted to solve 2x plus 4 is greater than 10, we need to focus on getting the x by itself. So guess what we should do to both sides first? Subtract 4. By subtracting 4 from both sides, that will get rid of one of the two numbers preventing the x from being by itself. So we get 2x on the left is greater than 10 minus 4 is 6. And then to continue getting the x by itself, what would we do to both sides? Since the 2 is multiplied, we would do the opposite, divide by 2. The 2's cancel and we get x is greater than 3. Well, that wasn't too bad. The number line is pretty easy. Find the number you're looking at, 3. Shade the correct side based on the inequality. Well, we want the numbers greater than 3. Those live to the right of 3. And on the 3, parentheses or bracket. Remember, a parentheses indicates that we do not want to include the endpoint, and that's dictated by whether or not it's allowed to be equal. Since this doesn't say or equal to, it just says x is strictly greater than 3. We don't want the 3, which means we need a parentheses. Greater than or less than, use parentheses. Greater than or equal to, or less than or equal to, use a bracket. And what would the interval notation for this be? Well, just describe it from left to right. From left to right, this goes from 3 to infinity. Parentheses on the 3, and infinities always get parentheses. So the hardest part about this, I think, occurs after we finish solving it, but even that part isn't that difficult. Now, sometimes the solving can be a little more challenging, such as in part B. Let's take a look at it. We're solving 10x minus 12 is less than or equal to 5x minus 13. Now, as you're jumping into these inequalities, you can already start thinking some things, such as, oh, this says or equals to, or equal to. So when I get to the number line, I'm going to use a bracket. Also, it's less than, so I'm probably going to shade to the left. Notice I said probably. Sometimes that can be deceiving. So how would we start solving this? There's actually a bunch of moves you can do first, but there's one I would always recommend. Here's an equation solving strategy, or in this case, inequality. If you're ever solving an equation or inequality, and your variable is on both sides of the equation, you need to fix that as soon as possible, because you will never get an x by itself if it's in 2 different places. So I'm going to start by getting rid of one of the 2 x terms. Now, which one should we get rid of? I usually get rid of the smaller one, the lesser one, if you will. Because by getting rid of the lesser one, the remaining x term will be positive. And I'd like to minimize the number of negatives if I can. So let's subtract 5x from both sides to cancel the x's on the right. And on the left, 10x's minus 5x's is still 5x's. By the way, the x's don't cancel here because we're not subtracting them. Here's 10x's. Throw away 5 though. You still have 5x's. It's like, here's 10 apples. Oh no, we lost 5 of them. We still have 5 apples. Apples minus apples is still apples. It just changes how many of them we have. Let's bring down the pieces we didn't mess with, the negative 12, the less than or equal to, and the negative 13. And now this is pretty much just like the previous problem. Start stripping the x down. Let's start by adding 12 to both sides. That will cancel the minus 12 on the left and leave a 5x less than or equal to. On the right, negative 13 and positive 12 is negative 1. And then our last move is to divide by 5. Or try to divide by 5, which succeeds on the left. It's the reason we did the move. But on the right, I just set up a fraction that I can't reduce and I can't divide. So I'm left with x is less than or equal to negative 1/5. For the number line, well, think about the number line. First, let's locate negative 1/5. There it is. Again, when you're looking for a single number, you can put any number in the middle that you want. Where are the numbers that are less than that? Well, to the left of it. Shade into the left. And at the boundary point at negative 1/5, do we want to include it? Well, it says less than or equal to, so it's okay if it's equal to negative 1/5. We want to include it, which means we use a bracket. It would be a closed bracket because it has to open towards the left. And so our interval from left to right, don't forget, forever to the left is negative infinity, comma, negative 1/5. It's always left to right. Infinities always get parentheses, but this negative 1/5 got a bracket. So solving a simple linear inequality is pretty straightforward, and representing the solution set isn't that bad either. In the next video, I'll show you some things that can go wrong, not really wrong, but different with linear inequalities. And then beyond that, we'll take a look at some more powerful inequalities.